Okay, so I'm excited because this is the last set of videos I'm making for Calculus 2. So I'm excited, but it's going to be a lot of them. So bear with me. Um, let's start. I'm going to do a little bit of motivation of Taylor series and power series. Okay, power series, Taylor series, the line between them is a little bit blurry. Um, but let's do a little motivation from diffie-q. Okay, so let's suppose we know that there exists a function y of x, okay, such that the derivative of y prime, the derivative y prime of x equals y of x, and y of 0 equals 0, or 1, sorry. Okay, now we actually know the answer to this. You may not know it right away, but if you're, astute, you might notice, hey, that's just e to the x, right? Derivative of y of e to the x is e to the x, and y of 0 is 1, okay? Now, that one's one we know how to solve, so it's not really hard. It's a basic differential equation, so it will be something you learn how to solve pretty much the first or second day, all right? But we also want to look at it, we're going to use it as sort of a starting off point. We're going to assume a series solution. So that's something that you can do. In fact, most differential equations in practice are solved by series solutions, okay? So we assume a solution as a power series. Okay, so y of x, we're going to say is, let's use a. I'm in the mood for a's. a0 plus a1x plus a2x squared, so on and so forth, which I'm going to write this as the sum, n goes from 0 to infinity, a sub n x to the n. Okay? Now, y prime of x equals y of x. So let's take our y prime. Y prime, now remember, we can differentiate term by term. Okay? So it's just going to be n a sub n x to the n minus 1. Okay? And we're going to do a little index gymnastics. And we're going to say, you know what, we want to start this. We don't like that -1 term. Also, when n equals 0, and that's 0, so we can shift it. So we're going to write this as n plus 1. So now we're saying that we're still starting from n equals 0 here, but now we've been shifting it. So if n goes to n plus 1, then a sub n goes to a sub n plus 1. And x to the n minus 1 goes to x to the n. Okay? So just check that the first couple terms match up. So when n equals 0, we get 0. That's not going to matter. N equals 1, we're going to get 1 times a1 x to the 0. N equals 0, we're going to get 1 times a1 x to the 0. N equals 2 here, we're going to get 2 a sub 2 x to the 1. N equals 1 here, we're going to get 2 a sub 2 x to the 1. Okay, it's starting to make sense. Now, we're going to set up the equation y prime equals y of x with y of 0 equals 1. Now, one thing that this is going to tell us, if we look here again, y of 0 equals 1, that means, well, we're plugging in 0 for all of these, a sub 0 equals 1. Okay, now let's take a look at this thing. Let's write this instead as y prime of x minus y of x equals 0 with a sub 0 equals 1. Okay, so now we're going to take and we're going to write the terms, the series. So this is the sum, or the series, and goes from 0 to infinity, n plus 1, a sub n, x to the n, minus, let me move this just a little bit, our y is here, n goes from 0 to infinity, a sub n, x to the n. I made a mistake. That needs an n plus 1 on it there. There we go. I knew I made a mistake because it wasn't going to come out right. Okay. So now we're going to get what's called a recursion relation. Now all this is still looking ahead. It's not really necessary for what we're doing in Calc 2, but you know, later on when you go to DiffEQ, you might want to look at this video again and be like, oh yeah, that's what they're talking about. Okay, so what we're getting is a sub n plus 1 times n plus 1 minus a sub n equals 0. And what we're doing here is we're saying at each n, the coefficients of x to the n should match. Okay. So now this gives us that a sub n plus 1 equals a sub n divided by n plus 1. Okay. Now, we know a sub 0 equals 1. A sub 1. A sub 1, then that's going to be 1 over 1. Right? So this is n equals 0. So a sub 0 is 1. N plus 1 is 1. So far, uninteresting. A sub 2. This is n equals 1. So this is going to be 1 over now 2. Okay, starting to get a little interesting. You may think a sub 3 is 1 over 3, but you would be wrong. Okay, why? Because a sub 3 is 1 over 3 of a sub 2. One-sixth. Okay. A sub 4. A sub 4 is 1 over 4 a sub 3, which is 1 over 4 times 1 over 6, 1 over 24. Okay, now, one thing I want you to notice. We've got this factorial here. Okay, why? Well, 1 times 2 times 3 times 4. The next one is 1/5 a sub 4, which is 1/5 times 1/4 factorial. Okay, so we repeat this pattern, and a sub n just becomes 1/n factorial. Okay, let me make a little more space so that we can get the punchline. So this leaves us with what we call our power series representation for e to the x, or our Taylor series representation for e to the x. Technically add x equals 0, both of these, or also the Maclaurin series of e to the x. In any case, e to the x equals 1 plus x plus 1/2 x squared plus 1/3 factorial x cubed. Keeps going on like that forever. From 0 to infinity, 1/n factorial x to the n. Let me just say this. If I had the power to retroactively fail students that come to Calc 3 not knowing this relationship would retroactively fail Calc 2. Okay? Just so you know, that's how, this is one of those sort of critical things you should know or you should have gotten from your Calc 2 class. Okay, all right, I'll see you in the next video. We're going to develop the series for cosine and sine in the same way.